Okay, so the next doubt posted is the particle is projected vertically upwards with a speed of 16 meter per second. Okay, so I'm throwing something upward with 16 meter per second. After some time, when it again passes through the point of projection, which means it's going up and then vertical done, and then it's just returning back to the same point. Okay, so back to the same point. Its speed is found to be 8. So energy is lost. Okay, so it's coming down with 8 meter per second. It is known that the work done by air resistance is same during upwards and downward motion. Okay, so going up and going down, the work done or the energy lost against air friction is same. Okay, then the maximum height attained by the particle. Okay, so they want you to find this maximum height. Okay, so what I can do is I start with the given data. They have given me the initial velocity and the final velocity. So you see, if there is no air friction, energy has to be conserved. That is the initial energy that you give in should be the same energy I should get back. Okay, 16 means I should get back 16. But here I'm only getting 8, which means that the remaining energy is the energy lost against air friction. So what you need to understand is, so this is the energy, total energy initial is half mv square, v is this, and total energy final will be this. They are not equal. Why are they not equal? Because there's a non-conservative force acting, and that is air friction. Okay, you watch the class videos, you will understand the work per energy from the playlist. So you can do it multiple ways. You can use work energy theorem, or you can say work done by non-conservative force change in total energy. But I'm going to do it simply. Okay, the simple idea is the total energy final initial are not same. So why is not same? The difference is the work done by friction, air friction. The energy is lost. How much energy is lost? The work done by friction is equal to the difference in the total energy, because that's the energy consumed by it. Okay, so total energy initial is half m16 square minus half m8 square. This is the work done by friction for the full journey, that is going up and coming down. That much energy has been lost. So m by 2 I can take common. So I think 16 I can take 4 out. Okay, so if I take 4 out, so this is 4 square. If I take 4 out, this is 2 square. And since I've taken 4 out, it's 4 square out. Okay, so I'll be having m by 2 into 16 into, this is 16 minus 4, which is 12. So this is 696. So okay, I'll directly write down. This is equal to 96 m is equal to work done by friction. Again, you have to understand this is for upward journey and downward journey. Okay, so whenever there is friction or any non-conservative force, dissipative force, remember it will be equal to change in total energy, work done by the force. Okay, now I only need to find for upward. So therefore, for half of the journey, whether it's upward or downward, work done by friction will be equal to, or energy lost, work done by friction or energy lost. Okay, so it's equal. Work done should be negative here actually. Remember, I only taking the magnitude. Work done will be negative because it's dissipative. I've deliberately subtracted bigger number from smaller number. Okay, so it is half of this 96 m by 2, which is 48 m. So now what we have to understand is, okay, now I'm only going to look at the first half. In first half, you start with some energy, and the highest point, initially you have only kinetic energy, finally you have only potential energy. Okay, if there is no energy loss, they should be equal. Since there is energy loss, what is happening? If I start with some energy, on its path, I'm losing energy everywhere, and finally I'm reaching here. So which means the final energy I have plus the energy I lost should be equal to the energy I started off with. You need to understand that, because energy loss means it's being lost from the energy they already had. So I had this much energy, and finally I have this much energy. What happened to the difference? It has been lost against friction. So this one. Okay, so I hope you understand. Okay, so out of the total energy I had, I still have some energy left here. The remaining I have lost in its way. So the initial energy should be the final I have plus the one I spent on the way. Okay, so this is potential energy is mgh plus work done by friction. Again, for half of it is 48 m, and the initial kinetic energy is half m16 square. So this m goes off. This is 256 by 2. I need h, right? So minus 48 is equal to 10 into h. I hope this is clear. Okay, so this is 128. Sorry, 128. 128 minus 48 is equal to 10h. So this is 80. 80 is equal to 10h. So h is 8 meters. So it will reach a maximum height of 8 meters. Again, fully energy ideas. We can do it using work energy theorem also, but I think this is much more clear. The idea is energy, total energy has to remain constant. Okay, so what is happening is the initial energy you have plus the energy you spent will be should be the energy on the top. Okay, so I hope you understand this. If you have any doubts, post in the Telegram channel. If you like the video, hit the like button. Keep practicing. All the best.